We start with two chambers of heart, one atrium and one ventricle. That kind of heart can be found in groups of fishes as species. So they do have one atrium and one ventricle. So in that kind of organism, the flow of blood is just unidirectional. That is, it's just in one direction, one directional flow. As it is coming in, it is going out. Now in amphibians, they have in amphibians and reptiles, those sets of organisms have three chambered heart. That is two atrium and one ventricle. In this set of organisms, there is mixing of blood. I mean, a partial mixing of deoxygenated blood together with oxygenated blood. Now, what is deoxygenated? What is oxygenated? I remember explaining that the previous session. Oxygenated simply means the blood, the blood's hemoglobin has combined together with oxygen to give a bright red color. While deoxygenated simply means that the blood has not yet combined with oxygen. So the color of that is really kind of dark red. Are you all getting my point?
Yes, sir.
Yes, sir.
Okay. So right now, this is the human heart, as you can see on the board or the white screen here. This is the human heart. So you have right atrium. So yes, it is four chamber. So you have two on the left, you have two on the right. So please, you have to take note that all you are having on this side is considered to be your right, and all you are having on this side is considered to be your left. Just consider the image as a mirror image. What you are having on the right hand side, like on the right, is the left. What you are having on the left hand side is the right. So you just kind of need to, position yourself, like you turn your back. So when you turn your back, you expect that, okay, this is the left, this is the right. So this side is the right. Are you getting me now? This side is the left. Do you get that orientation, please? This is the right, this is the left. Do you get it?
Yes, sir.
Okay. So you have the right atrium, the right ventricle, the left atrium, and the left ventricle. Yes, so the heart is divided into these two parts by this line of division here. There is a line of division here called the septum. 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 Now that septum is the one that divides the heart into two parts. Now this side, which is the right part, you have this is the atrium here, this small part, and this is the right ventricle, this part here. Now on the left side, this is the left atrium, and this is the left ventricle. Okay, are we following, please? Hello, can we hear me?
Yes, sir.
Okay, okay, that's very good. So you can see, what's the function of the right atrium? The function of that is simply to receive the oxygenated blood. You can see the oxygenated blood. That means blood that hasn't combined yet with oxygen from the body via the vena cava. That should actually be vena cava. Why am I using vena cava? That is to put it in a plural form. Here, this is the superior vena cava. This is the inferior vena cava. They both opens directly into the right atrium. Can we hear me?
Yes,
Hello?
sir.
Okay. So as soon as the blood gets into here, you can see there are guidings here. These guidings are flaps, like flap of tissues. Let me put it that way. So the function of this thing here is to actually enclose this region from this region, kind of preventing the content of this one flowing into this when closed, and when opened it allows the content here to flow into this. Are you getting me now? Same thing on this side, the left side. You have these flaps of tissue that, when closed does not allow the free flow of materials from here down, and when open it allows the flow of materials from here down. Can we all still hear me?
Yes, sir.
Okay.
Yes,
So
sir.
the right ventricle, its own function is to pump blood to the lungs through the pulmonary artery. This is the pulmonary artery here. So once the blood moves from this right atrium, when there is, remember I mentioned that blood from superior vena cava, this is the superior vena cava, this is the inferior vena cava. The blood from those two are actually bringing blood from general body circulation. I mean deoxygenated blood now. We bring it, this one is bringing from lower part of the body, I mean that's the inferior vena cava. This superior vena cava is bringing the oxygenated blood from upper part of the body. So the two, their contents meet up here in the right atrium. So the blood will be piling up there, and when there is a sufficient pressure to cause this flap of tissue to open. Now this flap of tissue here is actually a valve. So the name I'm going to call this valve is what you call the tricuspid valve. Tricuspid valve. Tri simply means three. The cuspid there flaps. So it means this tissue here is a three flaps valve. Are we still together? Hello?
Yes, sir.
Okay. So when there is enough build-up of pressure within this right atrium, the pressure forces these flaps to open. Once it opens, the blood is able to flow into this right ventricle. Now, as soon as this ventricle here, phases, you need to understand, as far as the heart is concerned, is that you need to understand what they call relaxation and what they call contraction. You need to understand what they call relaxation, and as well you need to understand what they call contraction. So these terminologies, we are going to use something called systole and diastole for whether contraction or relaxation. So diastole is when the heart relaxes, and systole is when it contracts. Are you getting me now? Diastole is when the heart relaxes. Systole is when it contracts. So whenever there is already a build-up of pressure into this place, of course, this atrium and ventricles here, atrium can contract or relax, ventricles can contract or relax. They both exhibit those properties. Yeah? Give me some minutes. Marvelous. Alpha. Mo ń bọ̀ jàre. Jẹ́ n sáré. Aha. Hello, please give me some minutes, please. Okay. Alpha. I did. Ọ̀gá mi.
One of my papa friends to just come up from school. So
Okay.
don't do
My
myself.
chief, how you did that? Mo ń bọ̀ jẹ́ n sáré. Sorry. Hello, can you all hear me? Hello?
Yes, sir.
Okay, so sorry for the this for the break. So can we all still see the screen? Can we see the
Yes,
screen, please?
sir.
Oh, okay. Um, so we also have right ventricle here. So I said those two chambers, like those two times, atrium and ventricles, they can contract or relax. So whenever it contracts, is what you call the diastole. Whenever the ventricle contracts, is what you call the systole. So before moving fully into the heart contraction and relaxation, let's talk fully about these terminologies that we have on the screen. So look at the right ventricle here. It pumps blood to the lungs through the pulmonary artery. So this is the pulmonary artery here. So where it is usually going to is that it will go to the lungs. So any deoxygenated blood that's eliminated from this right ventricle is going straight to the lungs. So the function of the lungs is where you have gaseous exchange, oxygen coming in and carbon monoxide going out. So that's where you see oxygen mixes together with the oxygenated blood, and then the blood becomes red, like very bright red color. So before returning back to the heart. So here you have the left atrium that where the one that receives oxygenated blood returning from the lungs. You can see that here, and as well the left ventricle, which is the most muscular chamber. This one, you definitely see that the wall of this left ventricle, the one down here, is much more thicker than the one of the on the right ventricle. Why being that this one is much more muscular? Because it is performing more tasks. It is performing more it is performing more tasks. So it is much thicker. So that is why you see this one thicker than this one here. So when this one contracts, it pushes blood into this one. This is the aorta. Aorta. So the aorta is now the one that takes blood, you can see, to general body circulation. So we are still going to look into the function of the heart properly. So you can see I said the left ventricle is the most muscular chamber, drives blood through the aorta to the entire body. I hope we get this page.
Yes, sir.
Okay, few minutes please. Dámi sí ká fún yín lómi ni. Á bàbá yóò ṣe máa mú pure water tútù. Mi ti ṣetán, táìmù máa ṣetán ní. Where is my phone?
You go back to the phone.
Mi di pé round up tó bá ti di 9:40 nísìn. I will give them assignment fún parí náà. Ó ti sún mi lọ. Mo bọ̀. Okay, so let's quickly look into this this page here. So you can see the ensuring one way flow. So here you can see that we have different categories of valves: tricuspid valve, the bicuspid valve, pulmonary valve, aortic valve. So as I've mentioned earlier, this one here is the tricuspid valve. So it's the one guiding the entrance between the right atrium and as well the right ventricle. So this one is the pulmonary valve. This is the pulmonary valve, this is the aortic valve, and this is the mitral valve. So mitral or bicuspid, it is two flaps. It is two flaps. This one is three flaps. This tricuspid is three flaps. This one is two flaps. So this one is able to, whenever it opens, it makes oxygenated blood to flow from the left atrium to the left ventricle. Can we still hear me? Hello, are we still connected? Hello, can we hear me?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So, um, so tricuspid valve, that's between the right atrium and right ventricle. prevents backflow during ventricular contraction. So whenever the ventricle contracts, it closes so that it prevents the backflow of blood the into the right atrium. So you have the mitral or the bicuspid valve, which is between the left atrium and left ventricle, and it is the most common diseased valve. So you have that one here. So that's mitral. Pulmonary valve is a semilunar valve controlling flow, like it control flow from the right ventricle into the pulmonary artery, as you can see there. So this pulmonary from the right ventricle into the pulmonary artery, and then you have the aortic valve. It's also a semilunar valve regulating blood flow from the left ventricle into the aortic, so into the aorta. So this is the aortic valve, regulates the backflow of blood when the blood has been pushed through into this aorta here. So yes, the heart also has blood vessels. When we say big vessels, we said big, very big vessels. Can we hear me? Hello?
Yes, sir.
Okay. So when we say great vessels, we mean very big vessels that are carrying or taking massive flow of blood to the heart. So you have the vena cava. Remember, there are two: inferior vena cava and the superior vena cava. What they do is that they deliver the oxygenated blood from the body into the right atrium. That's the function. Pulmonary arteries, yes, that's the function of that is that they carry the oxygenated blood from the right ventricle to the lungs for oxygenation, as earlier mentioned. And you also have the pulmonary veins. Function of those ones is to return oxygen-rich blood, that is blood that has combined with oxygen, from the lungs to the left atrium. And then aorta, that's the body's largest artery, and the function of that is to distribute oxygenated blood from the lungs, from the left ventricle to all organs. So yes, the function of the heart is under electrical conduction. Electric conduction system. So the stimulus for contraction of heart is coming from the SA node, and this SA node is located at the right atrium. So you have the AV node, you have the bundle of this, and you have the Purkinje fiber. I'm going to give you these ones as assignments to go read on. Read on the SA node, where is it located and the function. Read on AV node, where is it located and the function. Bundle of these, where is it located and the function as well, and Purkinje fibers as well. So the ECG, yes, whenever someone is having issues with heart, maybe problems with breathing or something like that, it is expected, or it is the best investigation is for the person to go get an ECG done. That's electrocardiogram. So the electrocardiogram is just like a machine, like how should I put it now? A machine that's, it has some kind of electrodes that they are going to place on the chest, that's going to bring out the electrical activity of the heart. So it's going to print out a paper. So that paper printed out is what you call the electrocardiograph. So you have something like this. So this electrocardiograph, you have the P wave, you have the QRS complex, and you have the T wave. All these ones, I think it's not necessary at the moment, but please take note that electrocardiogram is what is able to translate, you can see, translate the heart's electrical activity into a visual waveform. So it's kind of give us how the heart is functioning, and how the contraction and relaxation is looking like. So from the electrocardiogram, you are able to see if the heart is having any issue or any problem. So because all of these things here, they denote something. So if at any point in time the heart is diseased, you can easily capture it from this diagram here. Okay, so P wave, KRS complex, and T wave, each of them, they have their function. P wave for the atrial depolarization, PRS complex, ventricular depolarization, and T-wave ventricular repolarization. We're still going to discuss more about this when we get to nervous system to talk about polarization, depolarization, repolarization, and hyperpolarization or hypopolarization. So the cardiac dynamics and performance. So basically, um, there are three key metrics that define how effectively the heart meets the body's demands, whether at rest or under stress. So the stroke volume, when we're talking about stroke volume is just the volume of blood ejected by the left ventricle with each contraction. Remember, the left ventricle is actually the main muscular part of the heart that that pumps out that that's when contract is able to push oxygenated blood into the general body circulation. So that blood that is ejected per beat or at a time is what you call the stroke volume, and it is expected that the stroke volume should actually have a range, but let's just give it a value here. Here you have about 70 milliliters. Heart rate is just an average resting beat per minute. So, and it has a range as well, usually from 60 to 100. So if it is less than 60, it is a condition, that's a disease, and if it is greater than 100, it's also a problem as well. So it is expected to have a range of 60 to 100 in a healthy adult. So 75, let's say if it is 75 beats per minute, and multiply this together, your cardiac output. Cardiac output is the product of stroke volume and heart rate. So it's expected to be about 5 liters. That's the total blood volume pumped per minute, and can increase by 5 during intense exercise. So meaning that when you have exercise, the blood that is pumped out is expected to be more than 5 liters a day. So sustaining cardiovascular health, you have all of these: exercise regularly, monitor blood pressure. It is expected that you're able to measure your blood pressure. Advise parents to measure blood pressure, check by their vitals regularly. The blood pressure, check cholesterol, check heart rate, so that we can detect any pathology or any disease of the heart quite early. And also respect the rhythm. Continuous uninterrupted blood flow is the key to human vitality. Every beat matters. So that will be that on that. So please, I've given assignments to go and check on this electrical conductor system. SA node, AB node, all of this funky J fibers. Can we still hear me? Hello?
Yes, sir.
Okay, any questions so far?
Yes, sir.
Any question? Why is this thing loading like this? Does anybody kind of how is this thing loading like this?